So welcome to the project demonstration of IoT transformer monitoring system. So here we are monitoring the temperature, current and voltage frequency of these two transformers. So here we have interfaced the LM35 temperature sensors on these two transformers. Coming to the transformer ratings, we are using 230 volts input, 12 volts output and 750 milliamps transformer rating. These two are. And the output of these two transformers is given as main input to this motherboard, and in that from one transformer we are taking a power source, because in order to making microcontroller working, so that 12 volts AC input is given as input to the, there will be a one IC. So here we can see this one is the DB107, which is full wave bridge rectifier, and after that we will get pulsating DC, and the pulses will be removed with help of this capacitor. We will get 12 volts pure DC voltage, and that 12 volts is given as input, power source input to this relay board, because we are using 12 volts operated relay electromagnetic relays to control these two loads which are attached in parallel to the two transformers. So these are representing as power transformer status. And the next, the 12 volts DC given input to the 7805 regulator. So 7805 regulator which will regulate the voltage from 12 to 5 volts. So, and after that there will be a red LED indication which will show the power status of the whole motherboard. And this is a reset switch to restart the microcontroller. And after that, on this, the steel plated one is a crystal oscillator which will provide the clock pulse to the microcontroller. The clock frequency is 20 megahertz. The main purpose of this crystal oscillator is, so we have given some set of instructions like reading input from these sensors and controlling the output like relay, and also sending data to the Blynk application through the ESP8266 module, and display the so-called status on the LCD screen. So these instructions will be executed whenever we tickle the clock pulse. So means one clock pulse per instruction. Like that we are providing 20 mega pulses per second, so that our microcontroller can execute 20 mega instructions per second. So here we are using 16F PIC 16F877F, which is 40 pin microcontroller. And coming to the interfacing from the inputs modules, like current sensor I1 and current voltage sensor V2. This is for transformer 2 and transformer 1, I1 and V1. So these are interface dates respectively A0, A1, A2, A3 pins of our microcontroller, and temperature sensor at E2 and E1 at this section. And next, frequency sensor interface at C0, C1 with these resistors, so that the microcontroller will count the number of pulses per second. And the Wi-Fi module B0, B1 interfaced, and B2 to B7 for this LCD, and these two relays at D6 and D7. So coming to the relay board. So here these two relays are used to control these two loads whenever the abnormal condition is placed. For example, coming to the currents. So the normality is below 200 milliamps. When it is above 200 milliamps, and the bulb will be isolated with the help of this electromagnetic relay. Coming to the voltage, 180 below or 245 above is abnormal conditions for the both transformers. Coming to the temperature sensor, so 45 degrees centigrade is the higher limit. Whenever the transformer getting heat up, then the temperature will be crosses 45 degrees, then the relays will be isolated, the same condition. And coming to the frequency also, whenever it is below 49 hertz, so just when we unplug this, then the frequency is going to be 0, and the microcontroller will isolate the power supply to the load. So the respective load for the respective transformers. So on this relay board, there we can see two LEDs which will show the status of the relays, and the two transistors. So each transistor is used to respective relays, because the microcontroller can't control 12 volt relay directly. So that's why we are going to trigger the transistor. Transistor will trigger the relay. Relay will allow the power to the bulb. So in this manner we are going to controlling that. And there we can see one diode on the relay board also. So the purpose of the diode is, whenever the inductor inside this relay getting on and off, nothing but it consists of a copper coil, so it will act as an inductor, nothing but. So when it is on and off, then the inductor will produce a back EMF. The copper coil will produce a back EMF that will be neutralized by this freewheeling diode, which is connected in reverse bias. So this is all about the connections. So let us see the demonstration. Before switching on the kits, we need to install a Blynk legacy application from the App Store or Play Store. And after that we need to change the hotspot name. So just go to hotspot settings in your phone, If you are using iPhone, then change the iPhone name to the project 4924 without any space, without any capital letter, and the password should be 129. So after enabling that, you can switch on the kit. But after enabling the hotspot along with data, then log into the Blynk application with given credentials, and generally there will be a red mark on this Arduino symbol when it device is offline. So now I'm just giving a power supply to this. Okay, so in 5 to 10 seconds the device will be connected to your phone and it starts sending the data. So it's continuously streaming to your Blynk application. We can see the V1, V2, so V1, I1, F1, T1. That's for the voltage, current, frequency transformer, temperature for transformer 1. And V2, I2, F2, T2 is for the transformer 2 readings. So now let me change the settings. So for example, let me increasing the current is I2 now. So we can see the I2 will be changes here. So whenever it crosses 200 milliamps, right, and then the T2 related transformer will be isolated, and we can see the Blynk notification also, and this particular notification will be get when you didn't open the application also. So now it is normal again, the bulb will be on, and coming to voltage, I'm increasing the V2 now. So right, so now we'll get notification of T2 high voltage, right, and the same manner it's normal now. Okay, so once it's normal, then low voltage. Right, T2 low voltage. Same high one. V1 low voltage. Again I set for V1 high voltage. Again now same, then V1 high voltage, right, and it is normal. And coming to the temperature, so just so when it crosses the 55 degrees, then same T2 will be isolated. When it is normal, again same will get high temperature already in Blynk application. So this data can be accessed through the Blynk app from anywhere in the world. We can access just by logging to the Blynk application, and also we can see n number of devices by logging to the Blynk application. Right, and coming to the frequency. So now I isolated the frequency now. Now the frequency at T1 is 0, same here also same 0, and they will get the low frequency alert. And this is the F2. Again F2 0, here also T2 low frequency. When it is normal again, so the power supply will be resumed to the load. Done.